GitHub has grown to have 10 million users and 30 million repositories. Getting to this scale has required innovation in many places, and GitHub has significantly altered the code for Git itself and has built unique infrastructure and written low-level code to architect for Git repository management at scale. Despite the need for cutting-edge technologies to support GitHub, the development culture at GitHub values tried and true technologies, and today's guest, Sam Lambert, explains the value of maintaining this tried and true technological philosophy with ideas such as maintaining a Rails monolith as the front end of GitHub and other battle-tested tools that GitHub uses. It's really a fascinating conversation about how engineering at GitHub works. Speaking of GitHub, if you go to softwaredaily.com, you can find the repo for Software Daily, an open source news and information site about software. If you're a web developer and you have experience with some tools like React.js or Flux architecture or Node.js or other tools, check out Software Daily. You can also go to softwareengineeringdaily.com, where you can find out how to become a host for Software Engineering Daily. You can find out how to contribute in other ways. You can find links to the Slack channel, my Twitter account. You can sign up for the newsletter, Software Weekly, where we curate content about software engineering. And with that, let's get to this episode about GitHub and Sam Lambert after a quick message from today's sponsor. I had a crazy idea a couple weeks ago. It's a photo sharing app that only has pictures of cats. When I finish my photo sharing cat application, I will be deploying it to Linode because Linode is the fastest hosted Linux provider. I don't want to get locked into a proprietary platform that's going to overcharge me as soon as my app gets popular. I just want a fast Linux server with simple pricing. Go to linode.com/sedaily and get $20 in free credit today. Plans start at $10 a month, so my free $20 will be plenty to launch my cat photo sharing app. Once I need to scale, I can use tools like node balancers and backups, and Linode has built-in dashboarding and metrics so that I can see the traffic to my Linode servers, and I can understand how many of my users are posting cat pictures and looking at each other's cat pictures. Go to linode.com/sedaily and get $20 in free credit today. The plans start at $10 a month, so it's a great deal. Thanks to Linode for sponsoring Software Engineering Daily. Now let's get on to this episode. Sam Lambert is the Senior Director of Infrastructure Engineering at GitHub. Sam, welcome to Software Engineering Daily.
Thank you. Thank you for having me.
GitHub has grown to have 10 or 15 million users. There's more than 30 million repositories. From a high level, what are the scalability issues that GitHub encounters?
So we're seeing a lot of growth at the moment, a lot of growth in users and usage, and it means that we're constantly, we're having to scale up in numerous different ways. One of them is the Git stack. So this is a new workload, really. There's no one is taking code hosted to this type of level and this type of scale. So we have people working on scaling Git specifically, which is something that hasn't, like I mentioned, has not been done before at this level. So we scale for us is starting to look like a number of bespoke different applications that are written by us internally. Stuff like custom load balancers, custom proxies, different ways to rate limit and monitor Git usage across our stack, ways of scaling out our workloads across multiple hosts. So recently we just finished a project that we blogged about called Spokes. What the project does is mean that we've completely changed how we store Git at the file server level. So previously we were storing using DRDB, and it was a fairly simple but unintelligent solution to storing Git. Git itself out of the box is not aware of the storage underlying storage infrastructure. And what Spokes does is we've added a 3PC client on top of Git that allows us to replicate Git into 3 places. It's a distributed system, and in that sense, we can lose nodes. We can scale out to more than 3 nodes. We can balance workloads across nodes. So we're working on a number of novel and different solutions to scaling the Git workload itself. We're also scaling GitHub.com as it is the web app. It's not a gigantic scale web app by any means, but our sense of relative scale and leading in scale is all around the Git stack. But there still is challenges with scaling the web app itself. It's at its core, it's a Ruby on Rails app that we're slowly extracting smaller pieces out of, building them into smaller services, not necessarily microservices, but it's something. As the app starts to creak and grow and lose flexibility, we start to extract things out that way. And we've also got scalability around storing the data, the sort of the metadata, things like pull requests, issues. And we use MySQL for that, scaling those data sets, stores, building out multiple clusters. Scale's happening in numerous different areas, but the largest scale we're seeing right now is the Git stack.
What do you need to know about Git in order to be able to scale it?
I think you need a number of different types of expertise to be able to scale Git. We have team members and people that work on Git core specifically. So we've made a number of performance improvements to Git itself. So the better Git runs across our infrastructure, the less we have to provision. Essentially, the less workload intensive it is, the less machines we have to throw at the problem. So we have a number of people that have a lot of deep internal knowledge. There's certain elements of scaling Git that are just around file storage. Git is obviously stored on disk in a number of different files. Mainly the custom Git knowledge that we have internally for scaling Git is around the usage of Git core and then writing applications around that.
Okay, so when you are dealing with scaling Git specifically, if we're not talking about the metadata, we're not talking about the website itself, what are in what terms are you thinking of it? Are you thinking of it in is there a MySQL, a section of a MySQL database somewhere that represents somebody's repository and that is the bottleneck of scale that you're trying to hit? Or what exactly are the infrastructure elements that you need to scale in order to be able to scale the volume of people's Git repositories?
So you need to scale things around Git processes. We need to scale the availability of our MySQL infrastructure. We authenticate against MySQL when you access a Git repository. We need to scale the infrastructure that routes you to a file server. So we need to be able to accept inbound connections to Git proxying layer. We need to make sure that scales there, that we can then query the app to authenticate whether that you were to validate whether you're allowed access to that Git repository. That all needs to scale. So we need to scale out read replicas, so that our Git auth application can read against available MySQL clusters. We need to scale out just the physical footprint of the storage. It takes there's many terabytes of Git information within our infrastructure. Actually, just scaling the physical footprint there in terms of disk usage. We need to scale the availability of Git processes. We see a project we worked on recently was we were seeing massive amounts of concurrent Git fetches from CI farms that were causing problems with our internal file servers. Tens of thousands of processes stacking up. So to scale that and to actually make sure that one of the elements of scale is just doing less work. So we had a project internally that was able to basically pause all those concurrent requests while we cache the result of one of those requests and then serve all those requests at once from that final result. So when it comes to scaling that stack, there's numerous areas that we have to do it, but it's also looking at the things we can do more cheaply or less often or not at all.
Okay, so there was a lot of interesting stuff there. So let's take a small example about cloning. So if I wanted to git clone on some repository, what are the elements of that process of from the client side all the way to the server side, the cloning process? What are the elements of that you own, the aspects that you would have to scale if git clone started to bottleneck?
Well, there's a numerous. It depends how we could go extremely granular with that problem. We could look at our inbound network traffic. We'd have to make sure we have enough capacity there. We have to make sure we have enough machine capacity once you hit our infrastructure with that request. We have to work out where that request needs to go. So without giving away too much of our internal sort of secret sauce, to scale a git clone would be at a per repository level, right? So the repositories are all isolated out onto separate nodes. They're stored on we'd store around 400,000 Git repositories together on a single node. And they scale out across 3 nodes, so we can read across multiple nodes there. When in terms of going down to what else we need to scale, we need to scale the authentication tier, as I mentioned earlier. It's difficult to dice it that way, I think, because there's so many different areas involved in that stack when it comes to a Git clone. It's also it varies on the size of that repository. If the repository is extremely large, there's a number of internal bottlenecks around Git core that really some are fairly complex would take a long time to dive into. There's just numerous different elements across that stack when it comes to a Git clone that would have to scale all around, including the app, including our file storage tiers and our proxying areas.
Okay, sure, certainly. And I definitely understand we can't go super deep into every element of it, but this is definitely a technical show. I'd love to hear about the technical elements. So for example, when I clone a large repository from GitHub, like the Linux kernel, that clone could take a super long time. If there are a bunch of people accessing it at the same time, what kinds of things would you do to speed that process up? Whether if we're talking about the day-to-day speed of cloning something giant like that, or if there's like a thundering herd potential problem, what are the responses that you might have to lots of traffic? So imagine we get one repository getting extremely busy, so a large amount of clones happening. We have an internal service called Gitmon that monitors how much concurrency is happening at a per repository level and can actually rate limit and push clients back if we're getting too many sources to a single repository, so that you can't actually knock out a single repo with tons of usage. So that involved writing a rate limiting tier that was aware of our stack and could respond on a per machine basis to limit requests in that sense. So essentially we have to defend our clients almost against themselves so that we don't have this huge bomb of incoming requests coming in from Git clones. We'd also look at we can get traces of how operations are happening at the Git level, so we can look at where time is being spent. If there's inefficiencies, we'd have members of like the Git core team look into that. We have numerous amounts of monitoring around that area as well, so we can sort of see slowdowns. But some clones, can go on for a very, very long time. That's fine. A long-running clone is okay. It's like when there's a large amount of concurrency around that, that's when you can drag machines down. So it's around defending that infrastructure, making sure that you can't allow essentially the overwhelming of a machine or a number of machines. Mm. So talking about the broader scope of the infrastructure, the front end of GitHub is a monolithic Rails app, and you've spoken about the pragmatism of using Rails for this case, even though it may no longer be fashionable. Why did you come to this conclusion that Rails is just good enough, and it's also good enough to be monolithic?
So that's interesting question, actually. Right now it's pragmatic for us because it's the technology that was picked by our founders at the beginning. They did a lot of work to build the product in the early days. And right now developing a Rails app is still fairly simple. It falls down in the sense that it's not exactly simple to scale that Rails app. But from a development standpoint within our product, we still have engineers that can come in, use the underlying abstractions that Rails provide us, the speed that Rails gives us in terms of speed of development. And so right now, just chunking that Rails app for the sake of it would not be a pragmatic choice at all. It still pragmatically serves us to work around some of the difficulties and start working on the core of Rails and start fixing some of the underlying issues while we're still getting that quick development environment. So people can join GitHub, they can clone that app, and if they're familiar with how Rails works, they can get up and running and start making changes very, very quickly. So it serves us organizationally it's a skill set we can hire from. It's pragmatic to continue to rather than just reinvent the wheel and throw out all of that work previously without knowing why and without having metrics and have the app essentially tell you why you're going to start extracting things out. It's not pragmatic just to throw the monolith away for no reason at all. There's a lot of conversation around microservices, and I get it. I see why people do it, but I feel like microservices are a solution you have to know the problems first, and that may be a potential solution. But right now, just microservices for the sake of it also present just as many problems. And so it's pragmatic for us to keep that technology around and start extracting things as they make sense.
Can you contrast it with a product like Twitter? I don't think you've worked at Twitter, but maybe explain why at Twitter didn't Rails scale, and why is GitHub a different scenario?
The scale's massively different, really. For the although GitHub is a really well used site, and it's the number one place for developers to come and share and collaborate, it's still not at the scale of Twitter. We don't see the problems through the web app and through the web stack that Twitter would have. It's also largely it's around that. I know it didn't scale at Twitter. They're also the domain is quite different, I'd say, in what they're trying to do. So it's largely around that, I'd say.
Okay, so when you talk about how a lot of industry migrations to microservices might be premature, what do you mean by that? Like, are there alternative things they could be doing, or you just think basically until your infrastructure starts to bleed, you shouldn't start to do a microservice type of thing?
Yeah, I think you have to optimize for what you're trying to bring to the market and what people want from your service. And when you're developing early on, you're going to want to do that quickly. So bundling something into rather than working if you don't, without running something up and putting it in production, you don't know where it's a lot harder to find where your interfaces should be. When it comes to microservices, you're taking on a lot of extra overhead in the sense that you're now managing numerous different applications, deploying those all out separately, making sure they're going out without tight coupling. These are all things that people don't, and it's not inherently answered by microservices. I imagine people are running loads of repositories, loads of microservices, and probably bundling them together in one big deploy, which makes it monolithic in a sense anyway. Just to start with that, I don't know if it's always the most pragmatic choice. The main thing you should be spending your time on, if you can, is getting value to your users, and then working on scaling the thing that's providing value. And if it's quick to get up and running with a monolith and get moving, I would suggest doing that immediately. If you're very experienced and you've worked at large scale and you can think in services and you can draw off of your own experiences to know things that could be potential scaling problems up ahead, may be pragmatic to do it that way. But the thing is, you just don't know. It's going to surprise you. You're going to move the way you develop things. You're going to change things. Are going to it's really hard to conceive that architecture up front unless you have a very simple model, or you're it's very simplistic, the problems you're trying to solve.
Does GitHub look like if it doesn't look like a microservices architecture from inside, what does it look like? So what is the process for different teams spinning up different services that are reachable by anyone in the company?
It starts with that team deciding if the thing they're doing is fairly brand new or something that needs to be extracted. So we do have a number of lots of different services running. You maybe be able to enlighten me to what the difference between a service and a microservice is, where we decide one becomes a microservice and one doesn't.
It's smaller.
Yeah,
it's in a container.
Right. So that's it gets interesting. You see, the process here is we decide there's a use case. We decide it makes sense for it to be. So if it's reusing a ton of logic that's already inside the Rails app, and then we can move the Rails app to be deployed slightly differently and use all that logic, it may just be more pragmatic. It could be a number of weeks to extend that logic inside the app and move it that way. If it's something that doesn't make sense and doesn't use a amount of that logic, or we could build an API into the app that a smaller service could consume, we may look at it being that way. We take it use by use. The thing is, there's no hard answer. That's the problem with sort of dogmatic approaches to software development is, you just don't know the situations that you'll be in and how useful they'll actually be for you. So it's a case-by-case thing, fairly difficult to answer organizationally, and it depends team to team. But I feel like it's usually fairly clear when something needs to be separately deployed and be in its own service. The team would start creating the repository, start working on the code. We have various different ways to deploy your applications across our infrastructure. We're not running highly containerized environments right now, although that's something that we are looking at and investigating. Again, there's a lot of benefits to those types of environments, and we're certainly thinking about the benefits it could provide us. We still deploy out onto physical machines right now, straight out into the operating system. We use our chatbot to be able to do that, actually, to be able to deploy us if it was the cloud, but like physically within our infrastructure. The team would work on doing this machines, like essentially provisioning the nodes that would be necessary for them. There's ways of setting up those environments that are fairly uniform across our infrastructure, and they would just deploy from there.
Okay, we'll definitely talk about the chat bot because that's a very interesting topic of conversation. But talking more about the different components of the infrastructure, we talked about Rails. Let's talk about C. In the systems team, you use a lot of C. What kinds of lower level systems programming do you need to do at GitHub? Like, because on Software Engineering Daily, we haven't done many shows recently where people are talking about using C. So I'd be very interested to know what kinds of lower level programming you need to do.
We try and use C sparingly when it's not pragmatic to do so, or it can be done in a higher level language. But really, C is mostly around performance. Git itself is written in C, so there's no getting away from doing it there. Any of the customizations that we have to do to Git have to be in C. There's a few. The proxies that send you into the Git stack are written in C for performance mainly. We have some applications that need to keep a very large amount of connections active, which we use C in that sense as well. We do have a number of C developers. We have people that make core contributions to Ruby itself. Again, Ruby written in C, so that happens there. But it's not something we try and throw a C solution out to every problem. Just that the raw performance argument falls down a little bit when you think about that. It's not something everyone can understand easily. You get different security issues that can potentially come in with C, and there's a lot of just like sort of mental overhead to running C applications that you don't get from a higher level language. So it's dotted around. Systems team do spend some time writing C, but as lightly as possible.
When you talk about using C to change Git, so how often are you changing Git? Do you keep up with the? Are you changing the entire open source project of Git, or are you making custom alterations to a GitHub specific version of Git?
We're doing both. We run our version internally, which we deploy on our infrastructure, and we backport changes we make internally. We upstream them to the open source project. The most prolific committer to Git works at GitHub, and his time is mainly focused working on the open source version of Git, working on doing releases, making changes, and just generally improving the project and spending his time there. The Git infrastructure team that work on running Git in production will spend their time making changes to the internal version. Members of the systems team will do the same. If it's something that is generally useful and would be useful to the open source project, we would upstream that change. We also spend some of our time doing security releases for Git, blogging about those. We also spend time maintaining libgit 2. So there's a number of different things we do for Git internally and externally. Some of the internal use cases just wouldn't be applicable or useful to the open source community, and that we run those within our version, and then again spend time upstreaming the useful parts to the open source version of Git.
That's really interesting. Okay, so we've got all these new and interesting databases, but MySQL is the core database that you use at GitHub. You've been using it since the founding of GitHub. Why is MySQL a good and satisfactory fit for GitHub's use cases?
So initially, MySQL was picked by the founders when they were creating the application from day one, which was a choice that served us really well. Now, if we'd have picked a database that wasn't that good, I'm sure it would have been replaced in some point in our journey. Right now, the reason we still continue to use MySQL and invest heavily, is it provides us a lot of stability. It gives us exactly what we want from a database. We want performance, we want reliability, we want simplicity, which is the main thing we want from data. We don't want we don't want complicated, unreliable database. We want something that will store our data reliably and be retrieved easily. The scale out story for MySQL is very simple. The replication stream is very simple. We essentially, when MySQL does fail, which it does do, it fails in fairly predictable ways. It's not perfect, nothing is, but it's a 20-year-old project. It's building on strong foundations. There's a strong roadmap going forward. It's widely used. When we talk about scale, again, it's relative. It's completely appropriate for us to spend our time working on custom ways to store Git, for example, but not necessarily pragmatic for us when we're not scaling a gigantic scale web app to be rewriting databases, write our own databases, or use some of these newer kind of all-in fancy solutions. MySQL is the database of choice for a lot of the largest scale web apps in the world. Most of the large, like the Alexa top 100, I would say, would be using MySQL, and it's all for similar reasons. It's reliability, it's predictable, and it just does what you want from a database. You may not get all the shiny development features that you would in other databases. You do have to define a schema, even though that's not actually that difficult to do. Like if you don't have time to think of your schema up front, you potentially, you're going to pay that penalty somewhere in the future. So yeah, it just pragmatically does exactly what we want from that area of the stack very reliably.
Wealthfront is an automated investing service that saves you time. As an engineer, your time is valuable. If you want to invest, but you don't want to spend significant time evaluating your portfolio and allocating assets, take a look at Wealthfront. Go to wealthfront.com/SEDaily to open an account today and get a special offer for Software Engineering Daily listeners. $15,000 managed for free when you open your account. With traditional investment services, there are many humans in the loop that are doing things that Wealthfront automates away. When you pay the commissions and account fees of these traditional investment services, you're paying for work that could be done by a computer. So don't pay commissions and account fees. Maximize your gains with Wealthfront's Set It and Forget It investment automation. Check out wealthfront.com/SEDaily. It would support Software Engineering Daily, and it would introduce you to the world of automated investing. Wealthfront.com/SEDaily. Thanks to Wealthfront for being a continued sponsor of the show. Now let's get on with the show. Okay, let's talk about deployments. And at GitHub, much of the deployment is done via interaction with a chatbot that the company built. I'd like to start there. Why is a chatbot useful for deployment and broader use cases?
It brings all your context into one place. By making the way we work happen in chat, it includes everybody, and people can be there and witness things going on. 55% of the company are remote, so based away from San Francisco, all around the world. Having our work happen in chat makes it much easier to communicate what's going on. So if an issue was to happen now, I could jump into the appropriate chat room and just see that the site had been deployed, for example, or alerts or messages were coming in. We use HughBot to look at graphs and metrics. It pulls the context in rather than everyone working in their own terminal and then somehow sharing that context in another way, maybe by synchronously located near each other or whatever. It can happen in a place that's easily accessible by people all over the world in any time zone. And it also helps you teach by doing. When you join GitHub, a lot of the learning just happens by being in the chat channels and participating and watching how people work. It's great to just wake up in the morning, jump into a room, look through this chat log, see what people have been discussing. It has a URL forever as well. That discussion lives around. The graphs that we pull in midway through the discussion, the issues we link to, the pull requests we link to, it all happens. It's all logged. And it's a really empowering way to work that provides a lot of context and rich amounts of information.
What else can the chatbot do?
HughBot can do most things that you'd expect, like other kinds of scripting to be done at any company. So you can do fun and silly things with HughBot. You can pull GIFs into chat. You can find out what food trucks are up the street from our office. But you can also provision a physical machine. So you can say, give me X amount of machines in this role, and that HughBot will go and provision those machines so that they spin up and you can start adding workloads or traffic over there. You can, like I said, you can add like graphs. You can fail over our database clusters. You can lock a Git repo if there's strange activity, like you wanted to like shut down some usage. You can do basically everything. There's just most things you'd automate at any company, you can automate through HughBot and bring all that context in for everybody.
When I make a request to HughBot, what's going on in the back end?
So HughBot's a Node.js application, but then usually we pass the request through that application through to a set of scripts that we run out the back. So we have what's called the shell repo, which essentially houses a load of Ruby and shell scripts that do most of that orchestration, and then HughBot will just pass back the output from those scripts. So it means that we essentially don't have to write CoffeeScript to do all this type of orchestration. We can use Ruby, we can use shell, and it gives us that like extra flexibility. So essentially, you can do anything really with HughBot. You just pass it through. HughBot essentially just wraps a lot of that functionality.
So is there, how to what degree has this become institutionalized at GitHub? Like you mentioned, being able to provision machines. Was this like, once HughBot got going, there became an entire initiative to get as much functionality into HughBot as possible, and other teams had to participate in this, or did people just start contributing their own API endpoints for HughBot?
HughBot's been around. HughBot came out of the early engineering culture at GitHub, and meaning that HughBot's been around for quite a long time. So I wasn't at GitHub when HughBot was introduced, but the adaptation seems to be very broad. It's now just a way that we do things. It's not really shipped until you've built the chat ops to accompany it. So when you build a new service or add something new to the stack, or just add some minimal functionality somewhere into an application, if you want to control it, then you just add the chat ops. It just happens. It's just something that's known to do. It's the platform that we manage everything from, and so you have to, it's not really done until you've added it to HughBot. I think the company was early enough for it to HughBot to be seeded really deeply, in that sense that it was never like, oh, here's the decision to do this, let's start moving stuff over. I think the company was probably too small and too early for that to be for there to be any sort of significant overhead around adding HughBot. And now HughBot's here. It's just a constant thing that we all do.
And you mentioned that term chat ops. What is chat ops?
Chat ops is essentially operating your infrastructure or your services or your systems from a chat room.
Okay. And do you think that is this going to be a pervasive thing throughout other companies, or do you think this will just be, at some companies GitHub obviously it's baked into the culture. I don't know, do you think chatbots are overhyped or underhyped when it comes to chat ops, I guess?
I definitely am seeing it growing more and more. The more conferences I go to, the more people I speak to, more it's becoming more frequent the amount of times people will come and say to me, oh, we use HughBot internally ourselves. And I hear of more companies adopting that workflow and bringing it in-house. I think it's trending upwards. Slack, have integrated their platform. They have bots inside Slack. There's more and more companies starting up around chatbots and doing things through chat platforms. So I can definitely see it growing. I don't know if it's appropriate for every company to kind of use this type of way of working, but it works here. It's really enjoyable. It's a workflow that I like. I think it's going to increase in popularity, certainly. I would like to see it. It's certainly a very empowering workflow. I feel like I'd miss it, certainly not working in that kind of style. So I think so. I think it's going to grow in popularity. I hope so as well.
You think that it would be useful to have voice integration with the chatbot, so you could use your Amazon Echo or your Siri to say deploy?
Uh, yeah, I think it could be interesting. A couple of people have asked me that now. I would.
I mean, it seems a little far fetched at this point, but give it
Yeah,
a couple of years and probably not.
it could be quite funny, right? It'd be a kind of Iron Man type thing, I guess. You're sort of speaking to your servers directly. I don't know. I'm still not really using Siri on my phone properly. Maybe it's just something that I might be old fashioned now, but I personally don't know how comfortable I'd be talking commands out to a chatbot. But I would not be surprised if someone's working on something that will achieve something similar already. And I think it could be quite funny. I guess when you see these kind of CSI type shows where they're like dragging screens across on these and it's all like interactive and they're walking around in these kind of holograms. Maybe that is a future. Maybe chatting to HughBot would be the first steps. I don't know. It'd be fun to see, certainly.
Yeah. Okay. So I said we were going to talk about deployment. I just talked about the chatbot thing for 10 minutes. Describe the build and deployment process in a little more detail.
So the development and deployment process at GitHub is fairly simple. The underlying technology, obviously, it's a complex problem to deploy out to thousands of machines. It's not easy, not simple. But the way we essentially we do our development is using the what we call the GitHub flow, which is a very much simple workflow. You branch out from master. You create a pull request. We encourage people to create pull requests early. That way you can have maximum communication around the changes that you're making. So I sometimes will create a pull request that's just a file structure or just, some fairly empty files and then I will express my intent in the pull request body at the beginning and talk about what I want to build in that pull request. And doing that means you get the full value. Like I see people send pull requests at the very end when they've finished, and externally, that's not really in our culture to do it that way. And I think you lose the value of bringing people on that journey as you develop. So we would spike out a branch early. We would start working within a pull request. When something is ready to deploy and be tested, you would queue to deploy into production. You'd first of all deploy out to we have what's called the branch lab, which essentially deploys out to a node that is accessible to you. And so you can test your branch and see that it's running in that environment. You can obviously develop locally as well. You deploy to branch lab, test that it's working in a production environment that users aren't accessing. Then you deploy out to a canary environment, which gets a percentage of production. You'd watch our internal exception tracking systems. If it's all looking good, there's no elevated error rates. You can see the functionality yourself. You then roll that branch out onto production, which modifies the site completely. If you were to go to github.com right now, it's 12 o'clock on a Friday. You're definitely going to be running on a non-master version of GitHub. We're continually deploying the application. We deploy our various applications hundreds of times a day. We have this really iterative and quick workflow. You can push changes up and then have them see them out in production within 10 or 20 minutes of making that change. And so that's a really nice workflow to go through because you get to continually iterate and you don't have to make these gigantic pull requests and work on features in a kind of in these large chunks. You can make them smaller, keep making those changes, keep pushing out to production. So it's a really interesting workflow to watch. I think people really enjoy that style of development rather than kind of a release-based workflow. But that's basically how it's done here.
Well, that's continuous deployment, basically. Mm-hmm. I mean, how long does it take for a deployment to propagate to the entirety of the user base? Does it just depend on how sensitive the change is?
So there's numerous ways of doing it. To actually deploy the code out physically takes about 3 minutes. So you would tell HughBot to deploy.
Well, no, because I imagine you're exposing it. You deploy the code, then you expose it to 5% of the audience. Yeah. And if that works well, you expose it to 10% and so on.
Right, exactly. So to pop the code out, 3 minutes done. Whether or not people are going to see it or not, now that's different. So we have ways within the applications to essentially you can turn up adoption. So we start with staff shipping. So we essentially turn a feature on or a change for our organization and run with that for the duration. So we'd say, we've staff shipped a feature, please let us know how it's working. And then we see it ourselves. We dog food that experience first of all. So it's not gen pop, but it's in the code base and it's deployed out on our infrastructure. That would be step one. When we want to change, say, some back-end functionality that isn't user-facing, we can use like the scientist gem that was built here at GitHub to start rolling out the change or compare the old functionality with the new functionality. We also have a way of ramping up usage for our users by just going into an admin panel in the app that essentially says deploy to 10%, 1%, whatever percentage that you need, and that will ramp up that feature flag. We do that. We try not to. We can dark ship as well, so we can send traffic off to different parts of the application without the user seeing that difference immediately to kind of test performance regressions. But usually we would test performance in that way and through staff shipping, and then ramp up slowly over probably a day. It's not normal for us to really ramp up user adoption over weeks or months. It's usually done in the time of a day while we monitor, make sure that it's just fine for performance. But yeah, that's how we do it.
What about monitoring? What do you do for monitoring?
We run just normal internal monitoring infrastructure like Nagios for setting up alerts. We encourage our teams to own their own alerts and services in production. So we've got numerous ways that you can set. We've got sort of some custom apps that will allow you to set up an application and route it. An alert for an application and then route it to a specific team that would either like carry a pager or it would create an issue for them. So we have some automation that says, this is a severity 2 alert, so it wouldn't page someone, but it's going to create an issue with the information you'd need to make that kind of actionable. So that's what we do for monitoring alerting. We also run our like Graphite clusters internally to store metrics, and then we have some scripting via HughBot to pull those graphs in. You can save those graphs and then pull them in for people to share and look at in chat.
GitHub manages its own servers. Why not use a cloud provider like AWS?
So there's a number of different reasons. So GitHub started 8 years ago. It was initially on sort of some managed service providers as the company started, and it was moved over to our own infrastructure. There's kind of control elements that we need running a site at this scale that you don't often get from the cloud. So we want to be able to manage which providers give us routes through to our data centers. We want to be able to control things like BGP. We want there's various security elements that we want control of. We want, there's workloads essentially that don't work very well in the cloud. That our database workload really isn't appropriate for cloud infrastructure, nor is our Git workload. It gives us a lot of flexibility and control. We do use the cloud, though. We have internal services that run entirely out of cloud infrastructure. We use it when it's appropriate, but a lot of our prior art and infrastructure sunk cost is around running in our own data centers. So it's still the most pragmatic choice for us to do it that way. But when there's times when it's just more sensible to run a cloud workload, we would still make use of the cloud. But primarily the main of our applications and GitHub.com are running out of physical machines in our data centers.
There was a time when GitHub was on a more managed environment, though, right?
Mm-hmm.
Have you heard any stories about the migration process off of that? Like I did a show recently about Dropbox migrating off of AWS to their own servers, and it was a really interesting story. So I don't know if there's anything similar that you've heard at GitHub.
Well, I was there for part of the process. A lot of it was essentially a lot of shifting data and moving over to our own physical machines. It was still physical machines inside a managed environment, so it wasn't so fundamentally different as coming off a virtualized environment onto physical machines. The workload was pretty much understood, and we just provisioned over onto our own physical boxes. So I don't think our transition story would be as interesting in that sense. I did see a blog post about Dropbox moving a lot of their storage onto very densely packed physical machines, which was pretty interesting. But our transition story, our transition to our physical machines, our own managed physical machines happened about 3 years ago, so smaller scale. But I actually did the work to move our databases out into our new shiny data center when that happened, which was a lot of fun to have kind of brand new machines, spec to how we wanted, managed internally by us. It was a fun project.
Do you have an SRE role at GitHub like they have at Google?
Specifically SRE, no. We have the systems engineering group, which is as close...
And just for listeners who don't know, SRE is site reliability engineering, which is sort of this role of kind of managing the reliability of services.
Yeah, so there's nothing we call SRE. We don't call anyone DevOps role as having a DevOps role either. There's a lot of dogma around both, and I think there's a lot of approaches in both that are really useful, but we try not to, really name it that way. I still have to read the SRE book, which looks really interesting. There's chapters I've read that were good. No, not necessarily. I think we have roles that are very close and people who think within that way, but nothing we call specifically like SRE. We have the systems engineering group that solve problems using automation and with as little manual process as possible, which is important for any form of reliability, but not specifically SRE.
I saw this talk that you gave where you were talking about GitHub mostly relying on tried and true software like Rails and JavaScript and Git. And we discussed this a little bit earlier when we were talking about the Rails monolith being good enough and pragmatic. What about in the ops area? Can you get more cutting edge? Do you get more cutting edge? Because, monitoring software, it's obviously very important, but maybe you can be more on the cutting edge because if the monitoring software breaks, it doesn't necessarily break the end user.
It doesn't break the end user, but it breaks the ability to respond to problems that the end user is seeing. You can get cutting edge in any area as long as you understand that trade-off that you're making. And if you've spent well in other areas in the sense that you've not gone cutting edge everywhere, you buy yourself the time to run cutting edge in certain places. It's not about being completely dogmatic and like not taking on any new cutting edge technologies. It's about taking the ones that are really appropriate for that area. And you're right, we can get cutting edge in certain places. We're using some really cutting edge technologies around the place. They're not all in the critical path, and you build. And the point is, if you build in a way that means you're not tightly coupled to anything, because the truth is everything will fail at a certain point. It's not about if it's going to fail, it's when it's going to fail. If you build with the right practices, you can tolerate unreliable services. You just don't want them to be too unreliable. So we try for tested and true because we understand that what that buys us and what it gives us time to innovate on our product rather than constantly responding to unreliable services. And it also gives us predictability, and understanding how things will fail. But there's certainly, we're cutting edge in certain areas, and we're starting to, like I said, look into newer ways of running infrastructure, such as the DC OSs. And we do get room. We get the room and we apply it when we need to. But then there's other times where it's kind of there's just some problems that have been solved, and unless you're seeing lots of new and novel failures with those solutions, then you might as well stick with what the industry is doing and where common knowledge is.
You mentioned the DCOS, the data center operating system from Mesos. What about these different distributed systems management tools are appealing to you at GitHub? The DCOS or Kubernetes or whatever else you're looking at?
It's the social aspects of it are most interesting to me. So, meaning that for people to build a service or put something into production, they need to know less about the infrastructure that's underneath them, and then have to have less surface area and cross-team dependencies for getting things done. When you still have to consult with teams running underlying infrastructure, you can't move as quickly. If it's as simple as saying, here's a pipeline to build a container, here's the way you describe that way that container should look, build it, it will be spat out the other end of this pipeline and you can provision it to production. It gives us that kind of operability. It also means that we'd only have to manage an underlying cluster that the applications get time on. So it means you get some greater flexibility. Again, something we're not running in production, but it has those kinds of appeals, so it's definitely worth checking out and thinking about. Again, we'll have to make modifications to our Rails app, to various different applications that we run before we could do this kind of thing, but it's something we're certainly excited to experiment with.
What else is getting you excited about working at GitHub and doing infrastructure engineering these days as we begin to wrap up?
I think it's just exciting to me about how the company's growing, how there's this sense that, the work isn't over. There's so much we can do in the world and with our product. It's amazing to be able to contribute to a company that is genuinely making change and is building something that's the center of where software is happening, and how, as software engineers, we use the product. Our colleagues around the industry use the product, and it's exciting to be part of something that's so important to that process. It's exciting to see how we're growing the Git stack, growing that workload. And it's just fun to solve the challenge, the new challenges that are coming up in terms of growing an engineering organization and just being a company that's growing and doing exciting things.
It is the closest thing to a software engineering social network, it seems.
I think so. I think it's interesting to hear the stories of people that have kind of made just friends through open source, and it's happened on GitHub. It's really nice. It's fun to watch really lively discussions and issues and pull requests, and it's nice when people say, they got hired from GitHub, or like they used their GitHub profile as their work portfolio. It's really fun to hear that and to hear that people engage on the platform in that manner. It's fascinating.
Okay, well, Sam Lambert, thanks for coming on the show. This has been a great synopsis of how engineering works at GitHub. I really appreciate it.
Great. Thank you so much for your time.
Thanks to Symfano for sponsoring Software Engineering Daily. Symfano is a custom engineering shop where senior engineers tackle big tech challenges while learning from each other. Check it out at symfano.com/sedaily. That's symphono.com/sedaily. Thanks again, Symfano.
Wow.